let's go straight to the business. Expect questions like this in the examination. Alternating current in this examination you are preparing for. Alternating current. Look at this now. So in the diagram above, determine the root mean square current. See, this the root mean square voltage is 240 volts. This is the resistor, 4 ohms. This is the inductive reactance. This is sign for inductor. So this is inductive reactance measured in ohms already. If it is like inductor, it's measured in Henry H. But you have been given inductive reactance. The unit is in ohms. So you don't have to be just like, how can I solve this? If it's just like ordinary inductive reactance is 2 pi FL. But this thing has already been found for you as 3 ohms. So it's solved. It's very simple now. So we are going to solve this question, and we are going to solve this one. It says a capacitor of 20 times 10 raised to the power minus 12 farad and an inductor are joined in series. Calculate the value of an inductance that will give the circuit a resonant frequency of 200 kilohertz. Take pi square as 10. After solving this, we solve this and solve this as well. So let's go straight to the business. So we start with this very one. Oh yeah, let's go like this. If you know you are good, you can start solving it a bit before we finish it to see if we can get the same answer. Or you can just solve this question and see if it's the same as what I would get at the end of this solution. Alright, so now what we are going to do is determine the RMS current, that is the current. Let's do it here. The current, the root mean square current is equal to the root mean square voltage, RMS voltage over impedance. Impedance. You know that in Ohm's law, say V equal to what? IR. So now, potential difference, current times resistance. Now, current is potential difference over resistance, just like the same thing. Just like the same thing in relationship. But this one is in alternating current. That is why we are using the root mean square. Alright, so now, what we are going to do is, we have VRMS, but we don't have impedance Z. So we determine the impedance using these 4 ohms and the 3 ohms. See the formula for impedance. This is an RL circuit. This is an RL circuit. So the impedance of an RL circuit is square root of resistance square plus XL square. This is the formula. So if we solve this now, we get the impedance. Then we can finish this question. Alright, so what is our resistance? Our resistance is 4 ohms. So we say square root of 4 raised to the power 2 plus square root of what? 3 raised to the power 2. Oh yeah, like this. 4 raised to the power 2 is 16. 3 raised to the power 2 is what? 9. 16 plus 9 is 25. Square root of 25 is what? 5. This is the value of our impedance. Now we can finish it. Since we have Z now, impedance now, we can finish it. IRMS is equal to VRMS is 240 volts. So we write 240 over 5. Can you see it now? So 5 divide 24 will give you, I don't want to use calculator, will give you 5 remainder what? 4 remainder 4. 5 that for here, 5 divided 40 is what? 8. So the IRMS is what? 48 amperes. So this one has been solved. Now, this one is 48 amperes. So you can see that we have already gotten it now. So we can proceed to the next one. Alright. So permit me to clean the board. I hope you have gotten it. Permit me to clean the board now. So we repeat, we have to find the R square plus inductive reactance square. R is 4, given. XL is 3, given. So 4 square is 16, 3 square 9, 16 plus 9, 25. So square root of 25 is 5. So this 5 is for Z. IRMS equal to VRMS is this. 240 divided by 5 gives you what? 48. Okay, so let's look at this question. A A capacitor of 220 times 10 raised to the power minus 12 farads and an inductor are joined in series. This is capacitor 20. This is inductor. So this is series arrangement. This is series arrangement. So calculate the value of an inductance that will give the circuit a resonant frequency of 200 kilohertz. So we are looking for this inductance L here. This one is the capacitance 20 times 10 raised to the power minus 12 farads. So this is what we are looking for. So the inductance that needs to give it a resonance frequency of what? 200 kilohertz. Something like this. So this is an alternating current. So now let's look at the formula. Capacitance is given as 20 times 10 raised to the power minus 12 farads. Then inductance we don't know. Frequency is 200 kilohertz. We have to convert this thing to hertz. That is 200 times 10 raised to the power 3 hertz. K is 10 raised to the power 3. So 1, 2 plus 3, 5. That is 2 times 10 raised to the power 5 hertz. This is our frequency now. So now that we have gotten our frequency, we can proceed because we are looking for what? The inductance. So what is the formula that connects capacitance, frequency and inductance? Or capacitor, frequency, inductor? Now, frequency is equal to 1 over 2 pi square root of inductance, inductor times what? Capacitor. This is it. So this is the formula we are going to use now. Alright, so we can just put it straight or every other way. Alright, now let's remove this square root sign. Oh yeah, to remove this square root sign, square both sides. F squared equal to 1 over 2 squared is 4. Pi raised to the power 2. Then LC. That is, we have removed this square root sign. So square both sides. Even 1 is squared. 1 squared is 1. So this is what we are going to use now to finish it. So if we are to finish it like this now, let's finish it up here. Frequency is 2 times 10 raised to the power 5. So 2 times 10 raised to the power 5 raised to the power 2 is equal to 1 over 2. That is 4. Pi squared. We are given that pi squared is 10. So we write 4 times 10 times L that we are looking for times C, which is what? 20 times 10 raised to the power minus 12. Okay, so we take it like this. 20 times 10 raised to the power minus 12. Or we say 2 times 10 raised to the power minus 11. Any one, the same thing. So now, 2 squared is 4 times 10 raised to the power 5 times 2. That is 5 times 2. 10 raised to the power 10 is equal to 1 over 4 times 10. 40. 40 times 20 is what? 800 times L times 10 raised to the power minus 12. So 4 times 10, 40. 40 times 20 is 800. Then L times 10 raised to the power minus 12. So this is 1 over. So if we cross multiply it, we have 4 times 10 raised to the power 10 times 800 times L times 10 raised to the power minus 12 is equal to 1. It's equal to 1. So this is what we are making the subject. This L. So L now becomes 1 over all these. 4 times 10 raised to the power 10 times 800 times 10 raised to the power minus 12. That is 1 over 4 times 800 is 4 times 8, 32. Then 0 times 10 raised to the power 10, 10 raised to the power 10, 10 raised to the power minus 12, 10 minus 12. I'm just solving it gradually. 1 over 3200 times 10 raised to the power 10 minus 12 is what? Minus 2. So let this one come up. Alright, so this is 1 over 10 minus 2. 10 raised to power minus 2 coming up becomes what? 100. That is 10, 100. 10 raised to power minus 2 becomes 10 raised to power 2. 10 raised to power 2 is 100. So if it comes up, minus sign goes out. So that is 100. 1 times 100. You can say 1 times 100 over 3, 2, 0, 0. So 0 cancels 0. 0 cancels 0. 1 times 1. 1 over 32 what? Inductors is measured in Henry. So the answer is 1 over 32 Henry. That's it. So you can see it now like this. Inductance 1 over 32 Henry. So this one is solved. So I'm moving to this last one now. Let's solve this last one very quickly. Please, you can go through this very well and you can still try it and get it. If you are confused, just ask me questions. Mr. Primus is here to help you. If you are confused, ask questions in your comment section. Whatever you want me to do, just let me know that. I will do my best to that. Alright. So let's move to the last question for this very class. At what frequency would a capacitor of 2.5 microfarad used in a radio circuit have a reactance of 250 Hz? This is a very simple question. At what frequency? So what we have here is, first of all, you state your parameters. Frequency is what you are looking for. Now, capacitor C is 2.5 microfarad. This 2.5 microfarad means 2 times 10 raised to power 2.5 times 10 raised to power. Micro is minus 6 farad. Then we have frequency, we have capacitor used in circuit, reactance of. So reactance, capacitive reactance is 250 ohms. So you know now what is the formula for capacitive reactance? Capacitive reactance is 1 over 2 pi Fc. Now look at it. There is a difference between this question and this one. In this one, pi square is given as 10. Here, pi is not given. So our answer will be in form of pi. So let's fix the values there. Capacitive reactance is 250 ohms. 250 ohms. 1 over 2 pi. The frequency is what we are looking for. Capacitor is times F times 2.5 times 10 raised to power minus 6. So the same thing almost. So if we cross multiply, I have 250 times 2 pi times F times 2.5 times 10 raised to power minus 6 equal to 1. So the frequency now, F alone is equal to 1 over all these. 250 times 2 pi times 2.5 times 10 raised to power minus 6. Alright, let's do it now. Now we are going to do it now. So this 2.5 times 10 raised to power minus 6. We are solving this thing clearly without calculator. Right? So if we remove this point from here, if it goes from here to here, it makes it 10 raised to power minus 7. So we have 1 over the standard form. 250 times 2 pi times 25 times 10 raised to power minus 7. So this 10 raised to power minus 7 can come up so that we will now finish it. Alright, let's go. Please, 1 times 10 raised to power 7 over 250. So let me, because of the space, 10 raised to power 7 means 1, 0, 1, 2, 3, 4, 5, 6, 7. So that we can cut it and finish it. Times 2 pi times 25. Right, let's start dividing it. 0 cancels 0. Alright, let's start with 5. 5 divided 25 is 5. 5 divided 10. 2, 0, 0, 0, 0, 0. Don't mind, I'm just trying to do it and follow it very gradually. So we'll come to this 5 again. 5 here, 1. 5 in 20 is 4, 0, 0, 0, 5 in 80. Oh yeah, let's use 2 now. Let me see. 8000. So 2 here 1. 2 in 800 is what? 4,000. So 5 now 1. 5 in 40. 800. So long. So it's 1 over 800 pi. We have cut all these things remaining pi. So the answer, therefore, frequency is 1 over 800 pi. Tell it not to this calculator. So if this appears to be too long, we can still do it in our next video and make it like, okay, the short one, but I decided to like solve it bit by bit by bit. Alright, so the answer is frequency is 1 over 800 pi hertz. So this one is also what? Solved. So I thank you very much for joining us in this lesson. We're going to do more and more for our UTME candidates. God bless you. Please share this video to your friends. Expect more biology, chemistry, physics, English and math. Mr. Primus, thank you.